Hi everyone, we're going to talk briefly about the metric system, and we are going to talk about why we're using the metric system in the biology laboratory. The purpose of using the metric system in the biology laboratory is to make our lives a lot easier and our lives a lot more precise. We are using it to measure quantitatively or numerically things like weight and time and length and height and temperature. We are combining that quantitative data with qualitative data that is more subjective for color and smell and so forth. But when we're working on numerical or quantitative data, we use the metric system because we can work in units of 10. Working in units of 10 makes it much more accurate by avoiding errors that are associated with multiplying and dividing in fractions as we would in the English system. As a result of this, the metric system is the internationally recognized standard for science, and it is the internationally recognized standard for commercial measures as well, except not in the United States. And it's crazy that we don't use it in the United States, but you will really appreciate it in the lab because you will be able to scale up and scale down with exponents rather than with fractions. And so you can keep your measure in one specific number and move the exponents around and work with the units of measure and their prefixes. So let's look at the units of measure next, and then we'll look at the prefixes. In terms of the units of measure for metric, we have quantitative data in length, in mass, in volume, in temperature, and in time. And to go through those units of measure, for length, we are now using the unit of measure of meters as opposed to the English measure of feet, which was really fraught because you have 5,280 feet in a mile. But in meters, you have 1,000 meters in a kilometer. So it's just 1 meter times 10 to the third, 1,000, equals a kilometer. You're just moving that exponent back and forth as the numbers get larger. In terms of length, in terms of mass, in the metric system, we use the gram as the biological standard. And that is analogous to the English pound, although it's not that precise in science. So we like the gram very much because it measures the amount of matter, and it's easily scalable to kilometers, which are just 1,000 grams. For volume, we use the liter, and if we need to scale that up, you might hear about kiloliters, not very often, but you can hear about milliliters very often, right? That's scaling it down rather than scaling it up. The English equivalent, which is not a great equivalent, is ounces, which gets fraught as well. We won't even go there. For temperature, we use degrees Celsius as opposed to degrees Fahrenheit. And you might say, well, what does degrees Celsius have to do with the base 10? Well, degrees Celsius is kind of another measure. It's perfect for biology because the freezing point of water, which is the basis of life, is 0 degrees Celsius. So it makes it so easy to think about water being the freezing point at 0 degrees Celsius. And guess what? The next phase change to boiling is at 100 degrees Celsius. So it is base 10, and it is a beautiful thing as opposed to Fahrenheit, which for some strange reason is 32 degrees Fahrenheit when water freezes. And even stranger, it's 212 degrees Fahrenheit when water boils. So you can picture the subtraction, and it's not pretty. For time, though, English and metric stay the same at seconds. as the standard unit of measure. It's not minutes, it's not hours, it's not days, it is seconds instead. Very important for biology. Let's go into the prefixes next.